Hello, my name is Manuela Richter, and I am a sixth-year cell biology PhD student at UCSF in Sophie Dumont's lab. I'm excited to tell you today about my thesis work, which examines how cells build the machine of life. And this process of cell division has been characterized a long time ago, back in 1882, by Walter Fleming, who drew these beautiful salamander cells as they divide from one cell into two. And this is really the most essential process to propagating life. And what he remarked in these drawings were that there were these black squiggles inside of these cells. And he didn't know what they were at the time, but today we know that these are chromosomes that contain all of our genetic information. And today we also know that it's absolutely essential that these chromosomes are divided properly every time a cell divides. Any mistakes in separating these chromosomes can lead to cell death, to cancers, and to developmental disorders. So how do cells ensure that their chromosomes are segregated perfectly every time they divide? Well, cells build this machine called the spindle, shown here in green, which is a network of fibers that actually attach to these chromosomes to pull them apart into each new cell. And you can imagine that these fibers need to be very tightly coordinated, and they all need to have the correct length and position to make sure that the chromosomes end up where they're supposed to. So how these fibers get the correct length is my thesis work. And the first thing we thought of was that there are these two structures on either end of the spindle called the spindle pole, where all these fibers are connected and anchored. And we thought maybe these structures are essential for setting length. So using some molecular biology techniques, I actually got rid of these spindle poles, and we saw that these fibers still on average had the same length. So somehow they know on their own how long they're supposed to be. And we tested this a different way as well. So we took one of these fibers, we actually cut it using a high-powered laser. And we followed this shortened fiber over time. So we're going to follow this fiber at the top, and X will appear where I have cut it, and then the arrowhead will follow it as it grows back. And amazingly, we saw that these fibers are able to grow back on their own. So this tells us that individual fibers within the spindle somehow know their own length. And if you want to know more about this, please come find me and ask me questions at my poster. But essentially, we think that this self-organization of individual fibers is what the cell does to make sure that chromosome segregation happens properly in order to propagate life. And with that, I would like to thank ARCS for their generous support in allowing me to do the science that I do. Thank you.